Lesson 9.1, Right Triangle Trigonometry. Our essential question, how do you evaluate trig functions of acute angles? Find unknown side lengths and angle measures of right triangles, and use trig functions to solve real-life problems. Standard 9.1, number 2, evaluating trigonometric functions. So we're being asked to evaluate the 6 trig functions of theta, just like we have been. But now it's not given to us in a triangle, it's now given to us in a word problem, and we need to come up with the triangle on our own. So I know that I have a right triangle, so you're just going to draw a right triangle. So here is my right triangle. It's giving you one of the acute angles as theta, so just label one of them as theta. So here is theta. If that is theta, then I know that this over here is my opposite, and this one must be my adjacent. The one immediately across from the 90 degree has to be your hypotenuse. They gave us sine. So I had SOHCAHTOA. They gave me sine to be 4 over 7, which meant opposite had to have been 4, so this means 4. Means hypotenuse has to be 7, so here is 7. If I know sine, that means I also know cosecant, so this is just 7 over 4. Well, now I need to find the other 4. I don't know the other 4 because I'm missing adjacent. Because it's a right triangle, we are able to do a squared plus b squared equals c squared. I know one of the legs. I need to find the other leg, and I know the hypotenuse. Let's go ahead and solve. So b is the square root of 33. So this is the square root of 33. So now I need my cosine, so that is adjacent all over my hypotenuse of a 7. No rationalizing needed here because the denominator doesn't have the square root. But if this is cosine, secant is the reciprocal, and secant now has the radical in the denominator. So that means secant needs to be rationalized. So I have it 7 square root of 33 all over 33 as my secant. Tangent is opposite. My opposite was 4 all over my adjacent, which is the square root of 33. This needs to be rationalized. So we need to multiply both sides by the square root of 33. So my answer is 4 square root of 33 all over 33 for my tangent. Well, before I rationalized it, if you took the reciprocal, it would have been square root of 33 over 4. So there's my 6 functions. Let's do the next one. I have a right triangle, so draw our right triangle. You need an angle theta, so just make any of these acute angles theta. So I'm going to make this one theta. With that's theta, that meant this is going to be opposite. This one has to be adjacent. The one immediately across from the 90 degree is always our hypotenuse. So I have SOHCAHTOA, and they gave me cosine. So here's my cosine. Cosine is 7 over 10. Well, if I know cosine, I immediately know secant, so that's 10 over 7. I also know then the 7 was my adjacent, so it's a 7, and the 10 was my hypotenuse, so here's my 10. I need this opposite. So I need to do a squared plus b squared equals c squared. I know one of the legs, and I know the hypotenuse. So now I need to solve for the other leg. So let's go ahead and solve. So b is the square root of 51. So my opposite is the square root of 51. So sine is the square root of 51 all over 10, which meant cosecant is 10 all over the square root of 51. But you can't leave that radical in the denominator. We've got to rationalize both sides. So 10 square root 51 all over 51 is my cosecant. I already have cosine and secant, so now tangent. Tangent is opposite, so square root of 51 all over, adjacent to 7. Cotangent is the reciprocal, so this is 7 all over square root of 51, which meant I need to multiply both sides to rationalize. So 7 times square root of 51 all over 51 is the rationalized simplified answer. Let's go ahead and look at the next two. It says I have a right triangle, so you're going to draw yourself a right triangle. There's my right triangle. It says one of the acute angles is theta, so just make one of the angles theta. There's theta. If that's theta, that meant over here has got to be my opposite, which meant this side has to be my adjacent because I know immediately across from the 90 is always my hypotenuse. So I have SOHCAHTOA. So they gave me sine. So here's sine. Sine is 5 over 13, which meant the opposite is going to be 5. The hypotenuse is going to be 13, which meant I'm missing my adjacent. So a squared plus b squared equals c squared. And the only reason why I can use this is because it's a right triangle. So I know one of my legs, I don't know the other leg, and I do know my hypotenuse. So let's go ahead and solve for that missing leg. So b equals 12. So my missing side length is 12. So let's go ahead and find our other fractions. Well, I know sine, that means I know cosecant. So cosine is adjacent, which was 12, over the hypotenuse, which was 13. So my secant is 13 over 12. Tangent was opposite, which is 5, all over adjacent, which is 12, which meant my cotangent is 12 all over 5. None of these fractions simplify, so we're done. Last one. I have a right triangle. So here's my right triangle. One of these acute angles over here is going to be theta, so just pick one of them to be theta. If that's theta, then this over here has to be my opposite. This has to be my adjacent, because I know immediately across from the 90 degree is always my hypotenuse. Since it's a right triangle, and we only know 2 of the sides, we know we're going to have to do a squared plus b squared equals c squared. So it was tangent that we knew. We knew tangent was 12 over 9. Well, what does tangent actually give us? So here's so, ka, toa. So tangent actually gave us opposite to be 12 and gave us our adjacent to be 9. So we're missing our hypotenuse. So let's go ahead and solve for our hypotenuse. So we just found c, which is our hypotenuse, to be 15. So let's find the other functions. Well, if I know tangent, means I know cotangent. So here's my cotangent. Sine is going to be opposite, which is 12 all over hypotenuse, which is 15, which meant my cosecant is 15 all over 12. Cosine is going to be adjacent, which is 9 all over hypotenuse, which is 15, which means my secant is 15 all over 9. Now these fractions can be simplified, so you'll need to simplify the fractions. Both of these can be divided by 3, so I have the fraction 4/5, which meant this is 5/4. Both of these can be divided by 3, so I have 3/5, which meant this one is 5/3. Both of these can be divided by 3, which meant I have 4/3, which makes this one 3/4. There were 4 problems left on the page. Please do these 4 problems for independent practice.